Good afternoon. Last time I will discuss regarding the introduction about communication system and also various blocks in the communication system. In that I mentioned that regarding the modulation. So for transmitting the signal or message to a far distance, generally we need to modulate that signal. And also the modulation, we know that already I have told that in the last class that the definition of modulation is, it is nothing but a process in which one of the characteristics of the carrier signal, that may be amplitude or frequency or phase of the carrier signal, which is a high frequency signal, is varied in accordance with the instantaneous amplitude of the modulating signal. That is the definition. Or otherwise, this modulation is nothing but superimposition of high frequency sine wave with low frequency sine wave. So generally, according to this modulation, that may be categorized into three types mainly, that is amplitude modulation, frequency modulation and phase modulation. In this, already told that this is the modulating signal. In the modulation definition, I told that you may have the modulating signal as well as the carrier signal. The superimposition of this carrier signal on the modulating signal is nothing but the modulation. That's why I mentioned here, this is the modulating signal which is of low frequency signal, and this is a high frequency carrier signal which is of high frequency. So this amplitude modulation is defined as, it is a process in which the amplitude of the carrier signal is varied in accordance with the instantaneous value of the modulating signal is called the amplitude modulation. And the frequency modulation is defined as, this frequency of this carrier signal is varied in accordance with the instantaneous value of the modulating signal. Similarly, for the phase modulation, the phase of the carrier is varied in accordance with the instantaneous value of the modulating signal. That's why we are going to differentiate depending upon this modulation. This may be divided into AM, FM and PM. Actually, what is the need for modulation? Why it is required to modulate the signal? And also I told that if channel is in between transmitter, mainly we required three things. One is the transmitting antenna and a receiving antenna, in between that the communication channel. Depending on the channel, we require the modulation. If it is a line communication, we don't require to modulate the signal, whereas it is wireless communication. There is, if the free space is the media, then you have to consider this modulation. So here that need for modulation, there are five things are there. First of all, see, for easy transmission of the signal. So this easy transmission means, for easy transmission is, generally you have to consider free space as the communication channel or the medium in between the transmitter and the receiver. Then we need the antennas to radiate or receive this electromagnetic wave or electromagnetic energy. So for that antenna must be radiates effectively when the wavelength, when the half of the wavelength of the singer, this antenna height, where you have to put that antenna height, that the height should be half of the wavelength of the signal. That wavelength is nothing but this lambda. So suppose if you want to send 1 kilohertz signal from transmitting antenna to the receiving antenna, through communication channel or free space. If for 1 kilohertz signals, what height that is required to construct and design. So for 1 kilohertz signal, this antenna height should be lambda by 2. Already I mentioned that for effective radiation. So if antenna height is equal to lambda by 2, and also we know that lambda is nothing but c by f, where c is the velocity of light, that is 3.3 to 10 to the power of 8 meters per second. At that speed, the EM wave is also that propagate. That much of velocity. That's why I have to consider the velocity of light is nothing but the velocity of the electromagnetic wave. That's why that c is equal to 3 into 10 to the power of 8 meters per second, whereas the frequency, that is lambda by 2 into f, that is we are sending 1 kilohertz, that is 2.3. So 150 kilometers of height for transmitting 1 kilohertz signal. Is it possible? It is not possible. That's why impracticable to construct and install also. It is impracticable. So this height that has to be reduced to the minimum, that will be done by processing the modulation techniques, or that will be reduced by using this modulation techniques. And this process of modulation that provides frequency shifting or frequency translation. That's why in this modulation definition, I already told that is nothing but it is a high frequency component, high frequency signal superimposes the low frequency sine wave. That is nothing but the translation that process of modulation provides frequency shifting or frequency translation. That is audio frequency signals. Audio frequency signals are message signals, and radio frequency signals are the carrier signals. In this modulation, what you have to do? This modulating signal has to be propagated, or that will be traveled to a long distance through free space or the communication channel. Then this modulation process, this low frequency signal is going to be covered with a high frequency modulating signal, superimposition of the carrier signal with the modulating signal. This carrier signal is high frequency signal, whereas the low frequency signal or the audio frequency signal. So you have to convert this audio frequency signals are translated into radio frequency signals. So if 1 kilohertz signals, that same signal, here for this 1 kilohertz signal, we have to construct the height will be 150 kilometers. So for the 1 kilohertz baseband signal, you might have to call it as the message signal or baseband signal or modulating signal. That will be translated, this 1 kilohertz signal will be translated, or frequency shifts. Frequency is going to be shifted from 1 kilohertz to 1 megahertz, then antenna height will be C by F, that is C by 2F, that is 2 into 10 to the power of 8 by 2 into F means it is 1 megahertz signal, that is 1 10 to the power of 6, so 150 meters. The height of this antenna to construct or install. Here it may be 150 kilometers. This is only 150 meters. That's why this height is practically achievable. So for the modulation, it is one of the need for modulation. And second one is narrow banding. Means how this wideband will be converted into a narrow banding. Generally, if you assume that baseband signal or message signal in broadcast system that is radiated directly in with a frequency range, in that frequency range 50 hertz to 10 kilohertz. In that range, if you assume that the message signal is radiated directly. So this ratio of this 50 hertz to 10 kilohertz, so the ratio of this lower frequency to the highest frequency is only 200 hertz. So the antenna designed, you have to consider the antenna designed for 50 hertz and also the antenna designed for 10 kilohertz. So this 50 kilohertz, it may be 3000 kilometers. It is very difficult to that much of a height to construct or impracticable construction and installation. Whereas for this 10 kilohertz signal, the height will be only 15 kilometers. So for the transmission of this signal, we require a wideband antenna which operate the bandage ratio of this 200 kilohertz, which is impracticable. That is not possible. So what we have to do? The audio signal is modulated to radio frequency 1 megahertz. Audio frequency, then you have to modulate this low frequency signal to a radio frequency signal of 1 megahertz. Then that ratio, if you consider it, then lowest to highest ratio you have to consider it, then that will be 10 to the power of 6 plus 50 by 10 to the power of 6 plus 10 to the power of 4. This 1 megahertz means 10 to the power of 6 and 10 to the power of 6 plus 50 and the 10 kilohertz, that is 10 to the power of 4, 1 by 1.1 approximately unity. This ratio, lowest to the highest frequency ratio. So the same antenna will be this type of lowest ratio for if you translate or if you modulate the audio signal to the radio frequency range, then the same antenna is suitable for entire band extending from 10 to the power of 6 plus 50 to 10 to the power of 6 plus 10 to the power of 4 hertz. So the modulation converts wideband signal to narrow band called narrow banding. And another 3 parameters regarding the need for modulation. One is multiplexing. Multiplexing means many into one. In this, what happens if more than one signal uses a single channel. If you use a single channel, in that you have to send the more than one signal. If you uses for a single channel, the modulation may be used to translate to different signal to different spectral location. Means this has to be done by using the Fourier series. Fourier series are concerned that will be used for the periodic signals to represent a time domain to frequency domain. Means the translation has to be done. Whereas Fourier transforms are concerned, that is for periodic signals, that is also used for time domain to frequency domain, but that will be for aperiodic signals. Means this information in this, what happens is this has to be shifted into different spectral locations. So if you put like this, generally we can evaluate the information from that spectra comfortably. That is, then this need for modulation, this multiplexing is also one of the parameters. Next, equipment limitation. Equipment also having some limitation. Generally in signal processing applications, the frequency of the signal to be processed. Which signal you are going to be processed? That signal and a frequency range of a processing apparatus. Which apparatus are using for frequency range, that processing apparatus does not match. These two will not match. So that what you have to do is, thus frequency of the signal must be translated and modulation can be used. Again, frequency translation has to be done, in that the modulation that has to be done. And the modulation to reduce noise and interference. In the block diagram, I told that the channel is concerned, generally noise occurs in the channel or the free space. Means if we consider the channel as the free space, generally so many noises that are going to affect the signal, internal as well as the external noise. There is no communication. Without communication, there is no world. Without noise, it is not possible to get any signal. Noise must be there. Whatever different process and techniques and inventions, what we have done is, all these things are to reduce that noise level to the minimal level. So this noise and interferences are concerned, the modulation you have to use, in that these cannot be eliminated. This interference and noise cannot be completely eliminated in communication system. Only it is possible to minimize that effect by using certain types of modulation schemes. So the schemes generally require transmission bandwidth larger than the bandwidth of message signal. Transmission bandwidth will be more compared to the message bandwidth. So these are the requirements, and we will discuss each and every AM, FM, etc., PM in the next class. Thank you.